All right, well now we've come to the question that I'm sure you've all been dying to ask. What is the derivative of the inverse sine function? And so what we're going to do is we're going to start with just y equals, let's write it y equals arc sine of x. I don't know how to take the derivative of arc sine, that's the whole question, so I'm going to rewrite this thing in terms of sine. So y is arc sine of f of x, let's write it like this. If and only if sine of y equals x. And now I realize y is a function of x, and so I can take the derivative of this side using implicit differentiation, and I get just the derivative of sine is cosine, plug in y, times the derivative of the inside is dy dx, equals the derivative of x is 1. Solve for dy dx, and I get 1 over the cosine of y. And that's all fine and dandy, but not really. I could plug arc sine of x in for y, and I could have kind of a rather bizarre answer. But it turns out there's more to this story, and so I want to focus right here. Sine of y equals x. Like we saw in the previous example, you can draw a triangle associated to this statement. And so here it is. Let's kind of draw an arrow and set it up. So the triangle that I want to draw is, I'm going to think about y as my angle. Sine of y equals x means sine is what? Opposite over hypotenuse, so I get an x over 1. And so the Pythagorean Theorem says this side has to be 1 minus x squared, because when you square this side and add this side squared, then you'll get exactly 1. And so now, when I've got this triangle built around y, the angle y, and I come to cosine of y is just adjacent over hypotenuse. And so this whole thing reduces down to 1 over the square root of 1 minus x squared. And so this leads us to the following formula. The derivative of the arc sine of x is 1 over the square root, let's make that square root symbol later. 1 over the square root of 1 minus x squared. And you should also ask yourself, where is this formula valid? So scrolling up, think about the domain of arc sine. The domain of arc sine is minus 1 to 1, but at the endpoints, you've got this random endpoint there. You don't want to take a derivative at an endpoint. And so somehow that fact means you shouldn't be surprised when this formula is only defined for x strictly between minus 1 and 1. So arc sine, you can plug in minus 1 and 1. The derivative of arc sine isn't defined at the endpoints, and that's not surprising at all. So that is the derivative. Let's do an example. Maybe we could ask ourselves to take the derivative of this function. And so let's do it. So we get f prime of x is the derivative of arc sine is 1 over 1 minus x squared. So plug in x cubed plus 1 squared times the derivative of the inside is just a 3x squared. And so you can clean this up as 3x squared over the square root of 1 minus x cubed plus 1 squared. Now, if you wanted, you could expand this out and you would actually cancel a 1, but somehow it's perfectly fine with me if we just leave it like that. All right, very good. So we'll stop here for this video.